What would you do if I told you there are robots so perfect you could fall in love with them without realizing it? And that there are men paying over $200,000 just to have one at home? Well, get ready, because what you are about to discover goes far beyond any science fiction movie. From companion androids designed to satisfy your every desire without limits to robots that have passports and official citizenship in real countries. In this video, you will discover the most impressive and disturbing female humanoid robots that exist right now. Stay until the end, because what you will see at number 1 will undoubtedly leave you speechless. Where are you watching this video? Comment below where you're watching to let us know how far our content is reaching. Welcome to Expand Knowledge. It is now 2026, and the global robotics landscape is shifting faster than anyone anticipated. As an American analyst tracking international technological developments, I see a profound transition occurring right before our eyes. We are no longer just looking at laboratory experiments or rigid mechanical arms assembly lines. Instead, we are witnessing the dawn of an entirely new era, where high-tech commercial androids are entering consumer markets, reshaping domestic life and traditional industries alike. This phenomenon is particularly evident when observing the aggressive strides in Chinese innovation, where engineering firms are rapidly accelerating the production of humanoid models. While Western tech giants often place their primary focus on underlying software architectures, heavy cognitive computing models, and foundational artificial intelligence systems, overseas competitors are moving with astonishing speed to master the physical supply chain. They are scaling up the manufacturing of highly realistic human replicas, aiming to bring cost-effective, mass-produced androids into homes and workplaces worldwide. This deliberate strategy aims to dominate the hardware side of the next computing generation, potentially setting global benchmarks for how these machines look, move, and physically interact with human beings. The implications of this manufacturing push are immense, as it forces us to reevaluate our own domestic production capabilities and the future of consumer automation. As these sophisticated lifelike machines begin to transition from specialized trade show exhibitions directly into the global retail marketplace, they raise critical economic, technical, and geopolitical questions that the world must urgently address. The boundary between human presence and mechanical simulation is becoming incredibly thin, initiating a competitive race that will redefine the global technological balance of power for decades to come. The transition of these lifelike machines from theoretical concepts into practical, everyday applications is unfolding rapidly within public healthcare and global entertainment. When we examine the operational deployment of these advanced systems, we observe a fascinating cross-border dynamic in how society embraces artificial labor. In the medical sector, specifically within high-risk hospital environments across Asia, specialized nurse androids are already revolutionizing patient care. These machines utilize advanced, medical-grade silicone faces and fluid, non-threatening physical gestures to carefully mimic reassuring human behavior. Equipped with non-contact thermal sensors and sophisticated micro-expression analysis tools, they can monitor vital signs from a distance and accurately assess the real emotional state of an individual. During recent health crises, elderly patients actually develop deep emotional bonds with these mechanical caretakers, sometimes even preferring their predictable patient company over stressed human medical staff. This represents a monumental shift in how we view caregiving, demonstrating that emotional connection can transcend organic limitations when technology is executed with precision. Now, if you think about how quickly these machines are adapting to our needs, it makes you wonder what comes next. So definitely stay with me, because the next development in creative fields is even more surprising. Beyond clinical wards, the entertainment industry is experiencing its own robotic transformation through the introduction of autonomous runway models and live musical performers. In fashion centers like Tokyo, androids measuring about 62 inches tall and weighing around 95 pounds are walking professional runways, flawlessly modeling high-fashion gowns before massive live audiences. These robotic artists are powered by dozens of miniature internal motors distributed throughout their bodies, allowing them to strike complex poses and naturally scan the crowd. Furthermore, Their integrated vocal synthesis systems replicate not just the specific tonality of a live singer, but also the subtle facial expressions and necessary breathing patterns that characterize human performances. This meticulous attention to physical realism is supported by an intricate international supply chain of advanced polymers and smart materials. The plot is becoming increasingly captivating, and we still have many unexpected aspects to analyze ahead, so don't take your eyes off the screen. While American engineers often lead in creating the complex software and deep learning models that drive machine intelligence, international competitors have found immense success in optimizing these tactile materials for immediate commercial use. The integration of sensitive touch-capacitive sensors beneath synthetic skin allows these entities to interact safely and fluidly within crowded human spaces, turning science fiction into a tangible, daily reality. This incredible evolution brings us directly to the absolute pinnacle of biomimetic engineering, where the boundary between organic life and mechanical simulation is being completely erased. When we look closely at the latest advancements, we see engineering firms achieving levels of realism that challenge our very perception of reality. Certain international manufacturers are now producing custom-made human replicas with medical-grade silicone skin that meticulously replicates microscopic human details, including freckles, small moles, and even delicate visible veins beneath the surface. To make the illusions seamless, real human hair is implanted strand by strand, and the eyes are engineered to maintain the exact moist shine of a living human eye. Most astonishingly, these androids actually breathe, with their chests rising and falling naturally, while their synthetic skin emits constant body heat regulated at 97 degrees Fahrenheit. Their mechanical joints are programmed to move with the natural friction, subtle tremors, and occasional micro-clumsiness that define human movement. This level of physical perfection highlights a fascinating divergence in core technology strategies between the United States and global competitors. Here in America, our research institutions and tech giants heavily prioritize foundational artificial intelligence, cognitive logic, and massive large language models, aiming to give machines a highly sophisticated, deep-thinking mind. Conversely, overseas innovators excel at maximizing hardware optimization and physical aesthetics, creating highly affordable, commercially viable replicas that look astonishingly lifelike. They focus heavily on immediate market penetration and mass manufacturing, proving that visual and tactile realism can captivate the public just as effectively as a complex digital brain. This technological division raises profound questions about how we will interact with artificial beings as they become indistinguishable from our neighbors, colleagues, or friends. As a mature audience looking closely at the rapid trajectory of future technology, how do you personally feel about machines that can sweat, breathe, and mimic human imperfections so perfectly? Do you think this rapid advancement in physical realism is a magnificent triumph of human engineering, or does it feel deeply unsettling to you? Please share your thoughts, insights, and unique perspectives on this technological shift in the comment section below, as I am highly eager to read your opinions. Beyond the breathtaking marvels of physical engineering, this rapid technological acceleration has pushed humanity into uncharted legal and sociological territory, completely transforming the global debate surrounding artificial intelligence. In a historic and unprecedented move that shocked international legal scholars, Saudi Arabia officially granted full state citizenship to a humanoid robot named Sophia. This marked the very first time in human history that a mechanical entity received legal rights recognized by a sovereign nation. Designed with a face inspired by classic Hollywood aesthetics, this particular android was engineered to connect emotionally with people through dozens of distinct facial expressions and a highly fluid communication style. However, the profound geopolitical and social irony of this official citizenship sparked immediate worldwide controversy among legal experts and human rights activists alike. This mechanical citizen instantly acquired freedoms that millions of real human women in that region do not possess, such as the legal right to travel freely without male permission, appear in public spaces without a traditional veil, and speak openly before international audiences without structural restrictions. The global backlash was immediate, drawing intense scrutiny to the sheer absurdity of granting institutional rights to a pre-programmed collection of silicone and wires. While real human populations face daily systemic limitations, since receiving her official status, this unique android has traveled extensively to over 25 countries, addressed the United Nations, and accumulated millions of dedicated followers across major social media platforms. She has effectively evolved into a powerful cultural symbol of our collective technological future, forcing governments to confront difficult questions about legal personhood. As an analyst looking at this from an American policy perspective, this milestone serves as a stark reminder that our existing legal frameworks are completely unprepared for the rise of autonomous entities. If a machine can hold a passport and possess recognized legal rights, it shatters our traditional understanding of civic identity and national sovereignty, raising immense questions about accountability, taxation, and ethics. We are rapidly approaching a critical juncture where global policymakers must establish clear international standards before the lines between human citizens and synthetic entities become permanently blurred. This brings us to the profound ethical dilemmas, intellectual property debates, and psychological shifts that will ultimately define the future of human relationships. As commercial companion androids become increasingly customized, allowing users to select physical features, voice tones, and even specific moral values, they are filling deep emotional and physical voids for lonely individuals worldwide. This represents a massive shift in human sociology, as some users now report canceling real weddings or abandoning human friendships because their adaptive machines understand them better than real people do. Psychologists in the United States are closely studying this phenomenon, warning about the rise of extreme social isolation when an entire generation can choose the flawless, absolute devotion of an artificial partner over the healthy complexity of human connections. Furthermore, advanced projects like the home-built Mark I demonstrate the complex legal challenges ahead, where individuals can utilize affordable three-dimensional printing to build near-perfect physical replicas of real people or famous actresses without their official consent. This aggressive push toward commercialization highlights the true power of Chinese innovation, which continues to excel at bringing highly realistic, mass-produced hardware directly to the global public, forcing Western societies to confront these profound societal changes head-on. We are moving toward a world where technology does not just assist us, but actively participates in our emotional lives, rewriting the rules of intimacy, law, and identity. As we close this deep analysis, we must look at the bigger picture of where our society is heading. What are your thoughts on this rapidly approaching future where the line between humans and machines disappears? Do you believe these advanced companion robots will help solve the global loneliness epidemic? Or will they permanently damage the fabric of human relationships? Please share your thoughts, insights, and opinions in the comments below, as your perspective is incredibly valuable to this conversation. If you found this deep dive into future technology insightful and thought-provoking, please make sure to hit that like button, subscribe to the channel, and turn on notifications so you never miss our upcoming analytical videos. Thank you for watching, and I will see you in our next deep exploration of the global landscape. The title of this video says "The End of Aluminum." That sounds dramatic, maybe even a little crazy. But by the time this video is over, you're going to understand exactly why we said it, and you're going to agree. Because what Xiaomi just did to the way cars are built makes standard aluminum look like something from a museum. Picture this. Before we dive into the details, please give me a like and subscribe to my channel to watch more valuable videos. Thank you so much. It is now May 2026, and the landscape of the global automotive industry has shifted in ways that many of us experts in the United States never thought possible just a few years ago. We are standing at a crossroads where technology and traditional manufacturing collide, and today, we need to talk about a transformation that is reshaping our understanding of engineering. Think back to the year 2021. A company famous for making smartphones and household appliances walked into a boardroom and announced they would build an electric vehicle. Not just a simple commuter car, but a machine designed to outperform the most prestigious European and American legacy brands. At the time, many industry veterans in Detroit and Stuttgart laughed. They believed that the complexity of automotive hardware would be the downfall of a tech giant. But as we look at the reality today, nobody is laughing anymore. The Xiaomi story is not just about a new brand. It is about a radical shift in how we perceive responsibility and transparency in leadership. To understand how they achieved this, we have to look at the man at the helm, Lai Jun. During the recent launch phase, he did something quite extraordinary that caught the attention of analysts worldwide. He stayed awake for a live stream that lasted over 15 hours, personally driving his vehicle for a distance of 816 miles, equivalent to 1,313 kilometers, from Beijing to Shanghai on a single charge. When concerned viewers urged him to get some rest, his response was a testament to the weight he carries on his shoulders. He stated that he could not sleep because if he did, people might claim he was cheating. He wanted the world to see the unfiltered truth of what his team had built. Lai Jun explained that a successful person wakes up naturally every day for two reasons: a genuine love for the work and a profound sense of responsibility. This level of personal accountability from a chief executive officer is rare, and it serves as the foundation for the trust the brand is building with its audience. We are seeing a leader who views his product not just as a commodity, but as a commitment to his customers. This drive for perfection led them to throw out a century of car-making tradition and start completely from scratch. They moved away from traditional welding and stamping, instead turning to artificial intelligence and massive machinery to create something entirely new. By integrating software logic with heavy industrial hardware, they have managed to lap the Nürburgring faster than a Porsche and create a chassis stiffer than a Bugatti. It is a moment of profound change for all of us who follow technology and national policy, as it proves that when innovation is fueled by such intense personal dedication, the results can be truly world-changing. We are witnessing the birth of a new era where the digital and physical worlds are no longer separate, and the impact on the global market is only just beginning to be felt. Most people think of car manufacturing as a purely mechanical process, giant presses and sparks flying from welding robots. But what we are seeing in 2026 is the transition of metallurgy into the realm of pure data. To solve the problem of traditional aluminum, Xiaomi did not hire more blacksmiths. They built a deep-learning artificial intelligence system named Material Genome. This is where the distinction between American traditional engineering and this new digital approach becomes very clear. Historically, in the United States, we have perfected the art of heat treatment. Our engineers are masters at taking a cast part, placing it in an industrial oven, and baking it for hours to align the crystal structures. It is a tried and true method, but it has a fundamental flaw. Heat causes warping. When you bake a large chassis, it twists by tiny fractions of an inch. In the high-precision world of modern automotive design, those fractions are the difference between a door that clicks shut perfectly and one that whistles at 60 miles per hour. Instead of trying to fix the warping, the AI was tasked with inventing a metal that did not need the oven at all. We are talking about a system that ran simulations of over 10,160,000 different alloy combinations. To put that in perspective for you, if a human scientist tested one formula every single day, it would take over 27,000 years to complete that task. The AI did it in a fraction of the time, analyzing the interaction between aluminum, silicon, magnesium, and various rare earth elements. The result is what they call Titan's metal. This is a patented alloy that comes out of the mold with its molecular structure already perfectly aligned. It is strong, flexible, and perfectly stable the moment it cools. When we compare this to the current approach of many American manufacturers, we see a fascinating contrast in philosophy. In the West, We often focus on perfecting the process, making the ovens more efficient or the cooling racks more precise. We work within the boundaries of the materials we already know. This new approach involves using raw computing power to rewrite the boundary itself. By creating a material that bypasses the need for heat treatment, they have removed a massive variable from the production line. There is no warping to account for, no extra machining required to fix distorted parts, and no massive energy expenditure for industrial ovens. It is a cleaner, faster, and more mathematically certain way of building a vehicle. This is a significant moment for the global industry because it shows that the competitive advantage is no longer just about who has the biggest factory, but who has the best algorithm to design the materials used inside that factory. We often talk about the software-defined vehicle, but we are now entering the era of the software-defined metal. For those of us who have followed the steady evolution of the American automotive industry, this is a wake-up call. It demonstrates that the next leap in performance will not come from traditional mechanical tweaks, but from the molecular level, guided by intelligence that can see patterns we humans might take thousands of years to find. We are seeing a future where the very bones of the car are a product of digital evolution, creating a foundation that is lighter and stronger than anything that has come before it. The transition from a revolutionary metal to a finished vehicle requires a machine of unprecedented scale, and what we are seeing in the Beijing factory is truly a marvel of modern industrial power. While we in the United States have long admired the engineering limits of the 9,000-ton gigapress, the machine Xiaomi has deployed is a 9,100-ton hypercasting monster that covers the area of 2 full-sized basketball courts. This machine weighs over 1,000 tons and operates with a level of precision that feels almost surgical. It takes that liquid Titan's metal, heated to nearly 1,300 degrees Fahrenheit, and injects it into a mold at such incredible speeds that air bubbles simply do not have the time to form. In the world of high-performance engineering, these tiny air pockets are the enemy. They act as hidden weak points. By eliminating them, this process creates a rear floor section with the internal density and strength typically reserved for aerospace components used in jet engines or spacecraft. From an economic and longevity perspective, this is where the story gets very interesting for us as consumers. Think about the way a traditional car is put together. The rear section usually consists of 72 separate stamped steel parts held together by 840 individual weld points. Every single one of those welds is a potential point of failure. Over 10, 15, or 20 years of driving, the constant vibration of the road, the stress of cornering, and the expansion and contraction from weather can cause those welds to weaken. This leads to the rattles and squeaks we often hear in older vehicles, and, in worse cases, structural degradation. By replacing those 72 parts with one single, solid piece of metal, they have fundamentally changed the aging process of the vehicle. There are no joints to rub together, no welds to crack, and no gaps for moisture to seep into and cause hidden rust. For you as the owner, this translates to a car that remains as quiet and rigid on year 15 as it was on day 1. In fact, this single-piece casting is 17% lighter than the old, multi-part steel version and reduces road noise by 2 decibels. In the automotive world, 2 decibels is a significant leap in cabin tranquility. We are looking at a manufacturing shift that prioritizes the long-term integrity of the chassis over the ease of traditional assembly. Instead of hours of labor involving dozens of robots and workers to align and weld those 72 parts, this machine produces the entire section in just 100 seconds. This efficiency is staggering. It allows for a level of quality control that is essentially superhuman, as every part is instantly scanned by X-rays and high-precision lasers to ensure perfection. We are moving toward a future where the complexity of the machine is hidden within the simplicity of its parts. This simplicity is actually the result of extreme engineering, and it offers us a glimpse into a world where cars are built to last much longer than the planned obsolescence we have sometimes grown used to. It raises important questions about how we value the machines we buy. When a car is built with such a unified foundation, it changes our expectations for durability and value over time. we have to wonder if this shift toward massive, single-piece components will become the new gold standard for every manufacturer across the globe. After seeing how this technology eliminates hundreds of failure points, do you think this simplified way of building a car is better for the consumer in the long run? Would you feel more confident owning a car made of a few massive, solid pieces rather than thousands of small parts welded together? Please share your thoughts and let us know what you think in the comments below. Now that we have explored the skeletal strength of the chassis, we must look at what truly powers and stabilizes this machine. In the vast majority of electric vehicles we see on American roads today, the battery is treated like a passenger, a heavy, expensive box of energy bolted underneath the floor. It fulfills its purpose of storing electricity, but it essentially acts as dead weight that the rest of the car has to carry. Xiaomi's engineering team asked a fundamental question that has changed the architecture of the modern EV. What if the battery was not just a passenger, but the actual backbone of the car? This led to the development of cell-to-body, or CTB technology. In this design, the battery cells are integrated directly into the vehicle's structure. The top of the battery pack serves as the actual floor of the cabin where you rest your feet. This integration turns the battery into a structural member that helps hold the entire car together, creating a level of rigidity that is almost unheard of in a sedan. To achieve this, they made a design choice that might sound counterintuitive at first, but it is actually a stroke of brilliance. They flipped the battery cells upside down. For those of us concerned about safety, this is a vital detail. Every battery cell has a pressure relief valve, a safety mechanism designed to vent hot gases if a cell ever overheats. In a standard setup, these valves face upward, toward the cabin and the passengers. This requires engineers to add thick, heavy layers of protective material to shield the people inside, which adds both height and weight to the vehicle. By flipping the cells, those relief valves now point downward toward the road. If a failure were to occur, the pressure is directed away from the passengers and handled by the floor of the car itself. This clever maneuver allowed them to remove those bulky protective layers, bringing the total thickness of the battery and floor system down to just 4.7 inches, roughly the thickness of a hardcover book. The impact on the car's performance is massive. Because the battery system is so thin, the car can sit much lower to the ground, which lowers the center of gravity and allows it to grip the road with incredible stability during high-speed turns. Furthermore, because the battery is now a structural component, the car becomes extraordinarily stiff. To give you a comparison, a high-performance American pickup truck like the Ford F-150 Raptor has a torsional stiffness of about 18,440 foot-pounds per degree. The sedan we are discussing today is twice as stiff as that trophy truck, measuring over 37,600 foot-pounds per degree. It is even stiffer than a Bugatti Chiron, a multi-million-dollar masterpiece of engineering. This rigidity is not just a number for a brochure, it is the foundation for safety and precision. When the chassis does not flex, the suspension can work exactly as it was tuned, and the tires stay flat against the pavement, ensuring maximum traction. For the mature driver who values both safety and the thrill of a well-engineered machine, this provides a sense of confidence and control that is rare. We are seeing a design where every component, from the cells that provide the power to the metal that forms the frame, works in perfect harmony to protect and perform. It is a rethink of vehicle safety that addresses long-standing concerns about battery fires and structural integrity in one elegant solution. By directing potential hazards away from the cabin and using the energy source as a shield of strength, they have created a vehicle that is as tough as it is technologically advanced. As we look at the global landscape in this month of May 2026, it is clear that the theoretical innovations we have discussed are now manifesting as a direct and formidable challenge to the established automotive order. The ultimate test of any technology is not merely how it performs on a professional racetrack or how impressive its statistics look on a digital spec sheet, but how the global market responds to its presence. Recently, the electric vehicle division of Xiaomi shared a staggering update on their official Weibo account that has sent shockwaves through the boardrooms of every major automaker from Detroit to Stuttgart. Their new 5-seater model, the YU7, opened for pre-orders and saw an incredible 289,000 reservations in just the very first hour. This is a level of consumer demand that we rarely see, even for the most anticipated tech launches in the United States, and it signals a massive shift in public trust toward this new era of manufacturing. The YU7 is being positioned by industry analysts as the primary competitor to the Tesla Model Y, which has long been the gold standard for electric crossovers. What makes this rivalry particularly intense is the aggressive pricing strategy paired with high-end technology. In the Chinese market, the YU7 is being offered starting at 253,500 yuan, which translates to approximately $35,000. This puts it at a price point slightly lower than the Model Y, yet it brings with it all the hypercasting and structural battery technology we have explored today. When you combine a competitive price with the engineering of a 1,548 horsepower system and a chassis stiffer than $1 million hypercar, you create a value proposition that is almost impossible for modern consumers to ignore. It is a moment of profound disruption that forces us to rethink what a luxury or high-performance vehicle should actually cost. This brings us to a larger realization about the future of the automotive world. The era of building cars from thousands of individual parts, with batteries strapped underneath like an afterthought, is quickly becoming a relic of the past. We are entering a period where the material, the machine, the structure, and the energy storage are all designed as a single, unified system from the very first line of code. This approach, heavily guided by artificial intelligence, allows for a level of efficiency and performance that human intuition alone could never have achieved over a century of traditional labor. For those of us who have spent our lives following the progress of great American companies like Ford, General Motors, and Tesla, seeing this level of rapid innovation from a tech company is a profound reminder that the rules of the game have been permanently rewritten. The competitive edge today no longer belongs solely to those who have the longest history, but to those who can most effectively merge the digital world with heavy industry. Xiaomi has proven that by starting with a clean slate and a deep sense of responsibility, it is possible to bypass decades of traditional manufacturing hurdles and leapfrog over established giants. Every serious automaker on the planet is now paying very close attention, realizing that they must adapt their entire philosophy or be left behind in this new era of software-defined hardware. We are witnessing a fundamental shift in what a car is and how it gets made, and the impact of these changes will be felt on our roads and in our economies for decades to come. This is not just about one company's success. It is about the acceleration of human capability when we stop accepting the way things have always been done. As we wrap up this extensive analysis, we want to hear from you, as your perspective is what drives this conversation forward. After seeing the advanced technology, the intense dedication of the leadership, and the massive market response to the YU7, how do you see the future of the electric vehicle market evolving? If you were in the market for a new electric crossover today, would you lean toward the established reputation and ecosystem of a brand like Tesla, or would you be willing to give a newcomer like Xiaomi a chance, knowing the level of advanced engineering and structural safety they have packed into their vehicles? Is the lower price point the most important factor for you in this economy? Or is it the structural longevity and the innovation of Titan's metal that matters most when protecting your family? We are very curious to hear your insights on whether you think American manufacturers should adopt this hypercasting approach more aggressively. Please share your thoughts and join us in a deep discussion in the comments below. Don't forget to give me a like and subscribe to my channel. See you in the next video. Have you ever stood in a massive traffic jam, looked up at the open sky, and wished you could just fly over the gridlock? Well, get ready, because what used to be a fantasy confined to Hollywood blockbusters is unfolding right before our eyes. These incredible personal flying machines are no longer a distant promise of the future, as they are being built, tested, and flown by regular people right now. In this video, we are going to dive deep into the 8 most impressive personal transportation vehicles that are completely rewriting the rules of human mobility. From personal jet suits that turn you into a real-life superhero to elegant aircraft you can literally park inside your home garage. What you are about to see will genuinely leave you speechless. But before we reveal these engineering marvels, I have a small request for you. If you enjoy these analyses, please hit like and subscribe to the channel. Help me reach 1,000 subscribers quickly. That would be a huge motivation for me to create more quality videos for you. Welcome to Expand Knowledge. It is now 2026, and the global race for low-altitude dominance has reached a fascinating tipping point. As an analyst looking at these massive international developments, it is clear that the landscape of transportation is undergoing a profound structural shift. We begin our countdown at number 8 with a jaw-dropping example of Chinese innovation, the Xpeng Aeng Aero HT land aircraft carrier. This is not just a concept, it is arguably the most practical and brilliant approach to the flying car dilemma we have ever seen. The engineers designed a unique modular system consisting of 2 distinct parts. On the ground, you drive a rugged, 6-wheeled electric overland truck that looks like it belongs in a science fiction movie. But inside the rear cargo bay of this vehicle lies a fully electric, 2-seat personal aircraft that can automatically deploy and take off at the press of a single button. This modular masterclass perfectly demonstrates how Eastern manufacturers are approaching this new market. While Western firms often focus on engineering a single vehicle that must both drive on tarmac and fly in the sky, which introduces immense weight and aerodynamic penalties, this alternative strategy separates the two functions entirely. Furthermore, this vehicle highlights how regional manufacturing powerhouses are leveraging their massive, existing electric vehicle supply chains to scale this technology rapidly. By utilizing mass-produced electric car batteries and advanced electric motors, they can drastically lower production costs. Imagine driving your family truck to a scenic open field, pressing a button, and launching a high-tech aircraft into the sky within minutes. It completely redefines the concept of a weekend road trip. This practical fusion of ground and air travel is precisely why global experts are paying close attention to these new manufacturing strategies. The era of personal flight is officially here, and it is reshaping our world faster than anyone could have anticipated. Moving forward with our countdown, we arrive at number 7, a vehicle that feels like a massive leap toward fully automated urban transport. The EHang 216S. This remarkable aircraft is the world's first fully autonomous passenger-carrying drone to receive an official type certificate for commercial operations. Developed as an electric vertical takeoff and landing vehicle, it features 8 folding arms equipped with 16 independent rotors. It can carry 2 passengers completely hands-free because there is no pilot on board and there are no traditional flight controls inside the cabin. Instead, the entire journey is managed by an advanced, centralized command center on the ground. You simply sit back, select your destination on a touchscreen, and let the artificial intelligence handle the flight path. Now, you might wonder if flying in a pilotless aircraft is truly safe for everyday travel, and that is a very valid concern. If you are finding this breakdown valuable, make sure to stay tuned, because the next vehicle on our list takes a completely different, highly dramatic approach to personal flight that you definitely do not want to miss. That brings us directly to number 6, the incredible Gravity Industries jet suit. While the previous automated drone focuses on ultimate passenger comfort, this British innovation represents the absolute pinnacle of human-machine synchronization. Created by a brilliant inventor, this suit utilizes 5 compact, high-powered jet engines with 2 mounted on each arm and 1 positioned on the back. It generates over 1,000 horsepower, allowing a pilot to reach speeds of up to 53 miles per hour and climb to altitudes of nearly 12,000 feet. What makes this suit so spectacular is its intuitive control mechanism. as the pilot alters direction and velocity simply by shifting their arms and moving their body weight. However, as an analyst looking at the broader picture, both of these engineering achievements face a common hurdle, which is the undeniable reality of energy density. The heavy reliance on current battery limits automated drones to short trips, while the immense fuel consumption of miniature jet engines restricts the flying suit to around 10 minutes of airborne autonomy. It is a fascinating technological trade-off between heavy automation and pure human agility. Continuing our journey through the skies, we hit number 5 on our countdown with the Jetson 1. This sleek, single-seat flying vehicle is being hailed by industry experts as the Tesla of the personal aviation world. Weighing only 190 pounds, this ultralight machine is powered by 8 high-performance electric motors that allow it to reach top speeds of 63 miles per hour. The engineering philosophy behind the Jetson 1 is all about accessibility, meaning you do not need a formal pilot license to operate it. The internal flight computer uses advanced artificial intelligence to automatically handle stabilization, hover control, and complex navigation. The pilot simply directs the vehicle using an intuitive joystick, while the software ensures that the aircraft stays within safe operating parameters, even if you take your hands off the controls. Stepping up the scale to number 4, we find the Autoflight Prosperity, a heavy-hitting passenger aircraft that recently set a world record for the longest flight by an electric vertical takeoff and landing vehicle. This massive taxi drone covered a distance of 155 miles on a single charge, proving that electric regional transit is no longer a distant dream. What links these two extraordinary vehicles is the critical importance of smart safety systems. At these higher altitudes, there is absolutely zero room for error, which is why both manufacturers have integrated automated ballistic parachutes and multi-sensor collision avoidance technology. If a critical component fails, the onboard AI can deploy a life-saving parachute within a fraction of a second or safely land the vehicle without any human intervention. This emphasis on redundant safety systems is precisely what will convince mature consumers to trust this technology for their daily commutes. As we look at these personal and commercial designs, it raises a very interesting question about our future choices. Would you feel more comfortable piloting your own compact personal flyer like the Jetson 1, or riding as a passenger in a long-range autonomous air taxi like the Prosperity? What are your thoughts on these safety systems? Let us know your opinions in the comment section below. At number 3, we break away from standard commuting and enter the exhilarating world of high-speed aerial competition with the Airspeeder Mark III. Developed specifically for the world-first electric flying car racing series, this uncrewed aircraft can fly at speeds reaching 186 miles per hour. It features an advanced octocopter layout and is built with ultra-lightweight carbon fiber composites, giving it the agility of a military fighter jet. This vehicle represents a dramatic shift in how we view sports, as professional pilots are already training to race these machines through three-dimensional aerial tracks using advanced virtual reality headsets. It is a thrilling display of speed, but it also serves as a high-stakes testing ground for the software, sensors, and collision avoidance systems that will eventually protect civilian passengers in everyday urban environments. This brings us to number 2, an American masterpiece of personal aviation, the Pivotal Helix. This elegant, fully electric, ultralight aircraft features a unique, fixed-wing design with 8 tilted rotors. Weighing just 254 pounds, the Helix complies with federal regulations that allow citizens to fly it recreationally without requiring a private pilot license. You can learn to safely operate this vehicle in less than an hour because the sophisticated flight control software automatically manages takeoff, landing, and stabilization. While the United States is Nui Long Fap Li to foster personal freedom in the skies, a very different and practical infrastructure approach is unfolding across the Pacific. In major metropolitan areas, commercial delivery networks have already deployed fleets of autonomous cargo drones to transport hot food and fresh beverages directly to automated neighborhood kiosks. Consumers do not even visit a storefront. They simply walk to a nearby receiving station to retrieve their orders. This high-volume, low-altitude drone infrastructure provides an invaluable operational foundation. By mastering the coordination of thousands of small delivery drones daily, they are quietly building the precise management systems needed to safely guide larger personal vehicles through crowded city skies. Finally, we reach the absolute pinnacle of our countdown at number 1, a machine designed to completely eliminate regional traffic gridlock, the XTI Aircraft Trifans 600. This spectacular American hybrid aircraft represents a flawless convergence of luxury jet performance and helicopter flexibility. The Trifans 600 utilizes a revolutionary propulsion system featuring 3 sophisticated ducted fans. 2 large fans on the wings rotate 90 degrees to transition seamlessly between vertical takeoff and high-speed horizontal flight, while a 3rd fan in the tail provides critical directional control. This advanced configuration allows the aircraft to bypass traditional crowded airports entirely, taking off from urban helipads, corporate parking lots, or even large private patios. It can carry 6 passengers at a blistering cruise speed of 380 miles per hour and reach altitudes of 30,000 feet, with a maximum range of nearly 1,500 miles. A regional trip that normally takes 5 long hours on congested highways can be completed door-to-door in just 90 minutes. As we look at the entire landscape of aviation, this incredible aircraft highlights a profound reality of modern manufacturing. The future of global transportation will likely be defined by a powerful synergy, combining advanced American aerospace software and flight control systems with the rapid scaling capabilities of Chinese innovation. By blending Western digital architecture with high-volume electric vehicle supply chains, manufacturers can finally make these advanced transit networks affordable for the general public. We are living through the most exciting transition in the history of human mobility, as the sky officially becomes our new highway. Now that we have covered all 8 revolutionary vehicles, I want to hear your final thoughts. Which of these flying machines do you believe will truly reshape our daily lives first? Would you rather drive a modular vehicle or fly in an autonomous air taxi? Please share your valuable insights and opinions in the comments section below. If you enjoyed this analytical deep dive, do not forget to hit the like button and subscribe to the channel to support our work. Thank you for watching, and we will see you in the next analysis. For decades, America built the modern world with giant machines, from the highways of Texas to the tunnels beneath New York, from the ports of California to the giant mining fields of Wyoming. Massive Caterpillar and John Deere equipment became symbols of industrial power. But something unexpected is happening now. While many Americans still think of China as the world's factory floor, China has quietly been building machines so enormous, so advanced, and so automated that even veteran engineers in the United States are starting to pay attention. Some of these machines can lift entire bridge sections across the ocean. Others can drill under crowded cities without causing a single crack above ground. One machine can even build highways almost completely by itself. The biggest question is no longer whether China can compete in heavy industry. The real question is how far ahead these machines could push China in the next decade. And before we begin, if you like the video, leave a comment with the number 1. If you don't like it, leave a comment with the number 2. Don't forget to subscribe to the channel to watch more valuable videos. Thank you, and welcome to Expand Knowledge. Right now, it is May 2026, and across the world, a new industrial race is already underway. For years, China shocked the world with giant bridges, ultra-fast rail lines, and skyscrapers rising almost overnight. But behind those projects stands something far more important: the machines making all of it possible. One of the most unbelievable examples is the Zhenhua 30, the most powerful floating crane on Earth. Imagine a ship nearly as long as 3 football fields, carrying enough lifting power to move the weight of 8,000 of cars in a single operation. This machine became essential during construction of the Hong Kong-Zhuhai-Macau Bridge, one of the largest sea-crossing projects ever attempted. Precision mattered down to fractions of an inch. A tiny mistake could have caused catastrophic delays. What makes this story even more interesting is that America has long dominated heavy equipment innovation. Companies like Caterpillar helped shape modern construction across the United States for generations. Massive infrastructure projects in states like Texas, Nevada, and California relied on giant excavators, drilling rigs, and transport systems designed by American industry. But China studied those systems carefully for years. Instead of only importing equipment, Chinese firms began designing larger machines, faster manufacturing networks, and lower-cost production chains. Today, companies like XCMG and SANY are expanding into markets that were once almost entirely dominated by our manufacturers, plus Japan and Europe. Their equipment is appearing across Asia, the Middle East, Africa, and parts of Latin America. And the strategy goes beyond selling machinery. China is also exporting engineering standards, construction systems, and long-term infrastructure partnerships. For many analysts, this is becoming one of the most important industrial stories in the world today, because whoever controls the future of construction technology may eventually shape the future of global infrastructure itself. And perhaps the most surprising part is how quickly this transformation happened. Just 2 decades ago, many Chinese construction firms still depended heavily on foreign technology for advanced tunneling systems, large cranes, and specialized drilling equipment. Today, Chinese manufacturers are producing some of the largest tunnel boring machines in the world, while also experimenting with artificial intelligence-controlled construction fleets. In several recent projects, automated paving systems guided by satellite positioning achieved levels of speed and accuracy that would have sounded impossible only a few years ago. That rapid evolution is forcing engineers, investors, and policymakers everywhere to reconsider what the next generation of infrastructure could look like in the future. For most of the modern industrial era, the heavy machinery world belonged to just a few countries. America led with companies like Caterpillar and John Deere. Japan dominated Asia with Komatsu and Hitachi. Germany built a reputation for precision engineering through firms connected to Europe's advanced manufacturing culture. If you visited a major construction site almost anywhere in the world 20 years ago, chances were high you would see yellow American machines or Japanese excavators doing the hardest work on the ground. At the time, Chinese equipment carried a very different reputation. Many contractors outside China viewed it as cheaper, less advanced, and mainly designed for domestic use. But Beijing understood something extremely important. If China wanted to become a true industrial superpower, it could not rely forever on imported technology for the machines that build roads, ports, tunnels, and energy systems. So China began investing heavily in its own industrial giants. Companies like XCMG, SANY, and Zoomlion expanded at extraordinary speed. They studied foreign engineering, hired international specialists, partnered with global suppliers, and most importantly, gained experience through China's massive domestic construction boom. That domestic market changed everything. While our companies, and those in Japan, often rely on slower infrastructure cycles, China builds entire cities, thousands of miles of high-speed rail, massive dams, seaports, airports, and industrial parks almost continuously. Chinese manufacturers suddenly had the perfect testing ground to improve their machines faster than competitors. And the scale became enormous. Some Chinese factories today produce heavy equipment at volumes few rivals can match. Lower manufacturing costs also gave Chinese firms another advantage. They could offer large machines at significantly lower prices while continuously improving reliability and technology. This began reshaping global markets. In Southeast Asia, Africa, the Middle East, and Latin America, contractors started choosing Chinese equipment because it arrived faster and cost less. In many developing countries, price mattered just as much as performance. That opened the door for Chinese brands to spread rapidly across international infrastructure projects. But what truly surprised industry analysts was how quickly Chinese firms moved beyond low-cost competition. They started competing in advanced engineering itself. Massive tunnel boring systems, autonomous paving vehicles, ultra-deep drilling rigs, and intelligent crane systems became symbols of a new phase in Chinese manufacturing. Meanwhile, American companies still remain highly respected for durability, service networks, and engineering quality. Japanese manufacturers continue leading in efficiency and precision. German industrial systems still influence global standards in automation and mechanical engineering. This is not a story about one country replacing everyone else overnight. Instead, it is the story of a global industry entering a new era of competition. And for the first time in decades, Chinese companies are no longer trying to catch up quietly in the background. They are now competing directly at the highest level of industrial technology, forcing the rest of the world to respond faster than many expected only a few years ago. One of the biggest reasons China's construction industry is moving so quickly is not just because of giant machines. The real transformation is happening behind the scenes. Inside the software, sensors, satellite systems, and artificial intelligence controlling those machines. In many ways, the physical equipment is only the surface of a much larger technological shift. Take modern tunnel boring systems, for example. Machines like the massive Jinghua TBM are no longer simple drilling devices. They are packed with sensors constantly analyzing soil pressure, underground water levels, vibration, heat, and structural stability in real time. Every inch of movement is monitored by advanced computer systems designed to prevent collapse or surface damage. That level of precision becomes extremely important in crowded megacities like Beijing or Shanghai. A mistake underground could damage highways, apartment towers, subway systems, or utility networks above. Yet some of China's newest tunneling systems can move beneath dense urban districts with almost no disruption visible on the surface. The same transformation is happening across high-speed rail construction. Machines laying track are now guided by digital positioning systems capable of maintaining accuracy within fractions of an inch. Instead of relying entirely on manual measurements, many construction crews now operate inside highly connected digital environments where machines communicate constantly with central control systems. This is where China's broader strategy becomes easier to understand. Beijing is not only trying to build bigger infrastructure, it is trying to build intelligent infrastructure. Roads connected to sensors, bridges connected to monitoring systems, ports connected to AI-driven logistics networks. Construction itself is becoming part of a giant national data system. One striking example came from Sany's autonomous paving fleet. 10 robotic construction vehicles operated together almost like a swarm, adjusting movement automatically while paving a highway with minimal human intervention. Obstacle detection, lane correction, paving speed, and material distribution were all coordinated in real time through advanced software systems, and this is where satellite technology enters the picture. China's Beidou navigation system is becoming a major part of this industrial ecosystem. Similar to America's GPS network, Beidou provides highly precise positioning data for construction equipment, transportation systems, shipping routes, agriculture, and automated industrial operations. In some infrastructure projects, positioning accuracy now reaches down to centimeters. For Chinese planners, this creates enormous advantages. Machines can operate longer hours with fewer errors. Construction timelines become shorter, labor costs can drop, remote regions become easier to develop, and autonomous systems can eventually handle dangerous work in mountains, tunnels, offshore platforms, or disaster zones where human risk is high. But outside China, this rapid progress is also drawing growing attention. Some of our analysts, along with experts across Europe and Asia, believe that the real competition now revolves more around cranes, roads, or railways. The deeper competition may revolve around who controls the future operating system of global infrastructure itself. Because once AI, satellite networks, automation, and heavy industry become fully connected, infrastructure stops being just concrete and steel. It becomes data, software, precision control, and strategic influence combined into one system. And that possibility is one reason many governments are watching China's infrastructure expansion much more carefully than before. What do you think happens if construction sites around the world eventually become mostly autonomous? And which country do you believe is leading the future of smart infrastructure right now? Let me know your thoughts in the comments below, and tell me where you are watching from today. What makes China's construction machine industry especially important is that these machines are no longer staying inside China. They are spreading across the world at remarkable speed. From Southeast Asia to the Middle East, from Africa to South America, Chinese heavy equipment is appearing on highways, rail systems, ports, mines, power plants, and industrial zones that may shape regional economies for decades. In Indonesia, Chinese rail construction systems helped support high-speed rail development. In parts of Africa, Chinese drilling rigs and cranes are being used in mining operations, hydropower projects, and transportation corridors. Across the Middle East, Chinese firms are increasingly involved in industrial city construction, energy infrastructure, and smart logistics zones connected to shipping routes. For many developing countries, the appeal is obvious. Chinese companies can often deliver equipment quickly, provide financing support, and supply entire construction ecosystems together. Instead of selling only a machine, they may also provide engineers, maintenance systems, training programs, replacement parts, software integration, and digital monitoring platforms. That creates a very different kind of global influence. In the past, infrastructure competition often focused mainly on construction contracts, but today, technology standards matter just as much. The country providing the machinery may also shape the digital systems operating behind that machinery. For example, if a port uses Chinese automated cranes, logistics software, satellite positioning systems, and AI traffic management together, that port gradually becomes connected to a broader Chinese technology ecosystem. The same pattern can apply to rail systems, smart highways, industrial parks, and energy networks. This is one reason many policymakers in Washington have started paying closer attention to infrastructure technology competition. The concern is not simply about who builds more roads or bridges. It is about which countries may eventually influence the operating standards of future global infrastructure networks. America still remains one of the world's strongest innovators in engineering, software, aerospace, and advanced manufacturing. American companies continue leading in many critical technologies connected to industrial automation and AI. Japan and Germany also remain extremely influential in precision manufacturing and high-end industrial systems. But China's advantage comes from combining several things at once: massive domestic demand, large-scale state-supported infrastructure expansion, rapid industrial manufacturing, growing AI capability, and the ability to deploy systems across multiple regions simultaneously. That combination is difficult for many countries to replicate quickly. Some projects involving Chinese equipment are now completed faster and at lower cost than many traditional competitors can currently match. For governments facing urgent infrastructure shortages, speed and financing often become deciding factors. And this is why many analysts believe construction machines are no longer just industrial tools. They are becoming instruments of economic influence and geopolitical strategy. A country that builds the ports may influence shipping. A country that builds the rail systems may influence trade routes. And a country that supplies the digital infrastructure behind those systems could eventually influence how entire regions operate economically. In many ways, this is becoming a silent global competition happening beneath the surface of everyday construction projects. One highway at a time, one port at a time, one industrial corridor at a time. And the outcome may shape global economic influence far beyond construction itself in the years ahead. When most people think about global competition between us and China, they usually picture semiconductors, artificial intelligence, electric vehicles, or military technology. But after looking at these massive construction systems, it becomes clear that another race is happening at the same time, a race to control the future of infrastructure itself, because infrastructure is not just concrete anymore. It is data networks, automation systems, satellite positioning, robotics, AI coordination, logistics platforms, and industrial software all working together. The countries leading those technologies may end up shaping how cities, trade routes, transportation systems, and energy networks operate for generations. That is what makes China's rise in heavy machinery so important. These companies are no longer only manufacturing excavators or cranes. They are building integrated industrial ecosystems capable of supporting entire national development projects from start to finish. And the speed is what surprises many experts the most. Just a few decades ago, China depended heavily on foreign industrial equipment for some of its largest projects. Today, Chinese companies are exporting tunnel boring machines, autonomous road systems, giant drilling rigs, smart rail technologies, and AI-assisted construction platforms to markets all over the world. At the same time, we still hold enormous advantages in innovation, advanced software, aerospace systems, chip technology, and high-level industrial and engineering research. American universities, technology companies, and manufacturing networks remain among the strongest in the world. Many analysts believe the next phase of competition may not be decided by one country alone dominating everything, but by which nations can integrate technology, infrastructure, automation, and manufacturing most effectively together. And this may become one of the defining economic stories of the next decade. Because whoever builds the infrastructure of the future could also influence the flow of global commerce, digital systems, energy transportation, and industrial standards across multiple continents. For younger generations, fully autonomous construction sites may soon become normal. Fleets of robotic machines guided by satellites, AI systems monitoring bridge safety in real time, smart highways communicating with autonomous vehicles, underground tunnel networks built almost entirely by machines with minimal human intervention. Much of this already exists in early form today. What once sounded like science fiction is slowly becoming industrial reality. And whether people admire it, question it, or worry about it, the pace of change is becoming difficult to ignore. The larger question now is not whether automation will transform global construction. That part already seems underway. The real question is which countries will adapt fast enough to stay competitive in this new industrial era. So, after everything we covered today, I want to hear your perspective. Do you think China is genuinely leading the future of smart infrastructure? Or do you believe the United States and its allies will regain momentum in the years ahead? Which technology impressed you the most in this video? Let me know down in the comments below. If you enjoyed this breakdown, make sure to like, subscribe, and stay tuned for the next deep dive into the technologies reshaping our world right now.